Good morning, 8th grade trailblazers. Well, it's morning for me, probably night for you. But I want to go ahead and combine two PowerPoints in one because they're short, and I don't think you really wanted to watch 4 videos this week. So I'm going to do 2 in 1 twice this week. So let's get started. The first one we're going to talk about is understanding science and society. So what we need to understand here is that science helps communities make decisions. So if you look at my screen, there's like an annual drinking water quality report, and living in Palm Bay, you get one of these every year. Your parents do. They probably turn around and put them right back in the recycle bin. But it's really important because scientists really help society, and we're a small society here at Southwest. We're part of a larger community that makes up Palm Bay, which makes up Brevard County, which makes up the state of Florida, so on and so forth. So scientists are always working in communities to help us live better lives. So as a consumer, and you guys are consumers on some level, believe me when I tell you that most of the things that are on TV are meant to market to your age group, but you guys probably aren't looking at like, how long is that going to last? What's the durability of it? Is it safe? You guys are looking at it like, what's the newest thing? I need this gadget. But as adults, we look at it a little bit differently for most of the time. We want to know the products we're buying are safe. We want to know how things work. Science is there to help us understand all of that stuff and how to protect ourselves. So you've seen the videos like with the crash test dummies with cars. So if I were to have a baby, which I'm not, but if I were, I might want to trade in my little sports car for something a little bit more safe. I would research that. I would see which cars are out there to help keep my family safe. Okay, so when we talk about science and decision making, we have to understand that in science there's always costs and benefits. Okay, for instance, a cost is an unreasonable result of taking or not taking an action. So it's not, when I say cost, I don't necessarily mean money. A benefit is a desirable risk of either taking or not taking a certain action. So in the graphic above, where they have that chemotherapy medicine, like there are costs and benefits to that. Chemotherapy, if you didn't know, generally makes a person feel really sick. It attacks their entire body. It's trying to kill cancer cells. And the problem with cancer cells is there are cells that we make. So our body the medicine can't distinguish between, quote, and unquote bad cells and good cells, so it kills a lot of them. The benefit is that hopefully that person doesn't have cancer anymore. So there's always costs and benefits associated with science. A cost and benefit right now, it's, we're getting out of summer, but there's mosquitoes because it rains all the time. So the city has, mosquito spraying trucks that drive around and spray so that we don't have mosquitoes. So the cost here is that, well, it's a pesticide. Here we are, fumigating neighborhoods with pesticides. But the benefit is that we don't have mosquito-borne illnesses, which there are some, encephalitis, meningitis, a bunch of different nasty little things that can make us sick. So there's always going to be costs and benefits. And you have to have that ethical mindset to be able to decide if it's worth the cost and the benefit. All right, so the work that scientists do totally changes society. So science influences society, and in turn, society influences the work of scientists. For instance, I have an iPhone 6. You guys all have these new Galaxy. We all have different phones, but we want to have a phone that does everything for us. We're not content with just having a phone that makes phone calls and texts. We want it to do so much more. So as consumers, we will purchase new technology to make our lives better. And in turn, all those companies, Apple and Samsung, all of them will turn around and make new technology so that it's useful to us. Political concerns are concerns that governments have about how to use their money, power, influence. So what's going on now, there's a big climate summit. And a few years ago, even when I first started teaching back in the early 2000s, we used to call it the global climate change debate. And it was very politicized. The Republicans a lot of times would say it's not happening, and they would trot out their scientists. The Democrats would say absolutely it's happening, and they will trot out their scientists. And where we are now is it's not really a debate. Global climate change is happening. Both sides have kind of agree that it's happening. It's irrefutable. The science backs it up. But politics does come into play with different countries. For instance, in America, we don't do a whole lot of stem cell research because as a country, we find it unethical. However, if you go to some European or Asian countries to research or use stem cell research is perfectly ethical, and that's where a lot of that research happens. So it just depends on the politics of the countries involved. Social concerns are huge. As a leader among nations in the world, America, long partnered with other great nations, is constantly striving to help developing nations become more safe, help the environment. Disease is huge. If we look at the African continent and some parts of the South American continent, they don't have the water treatment that we do. They don't have the disease protection we do. So yeah, science totally helps to alleviate some of these social concerns. Money, money, money. Money is a motivator for most things and oftentimes blows out the social and political aspects of everything else. So science is there. It does provide jobs. It helps to lower the cost of goods. When computers first came out, they were astronomically priced, and now every one of you probably has one, maybe even two in your houses. It just becomes so commonplace that it lowers the cost of good. When a new drug comes on the market, it's crazy expensive until the patent runs out, and then generics are being able to be made. But yeah, science totally influences the economy. All right, that's it for the other one. Bear with me for 2 seconds so I can switch to the other one, which is a little bit of a downshift. So just keep up with me because we're going to switch from how science helps society to what's the difference between science and pseudoscience. All right, so scientific investigations really just involve things that we can observe. We have to be able to collect empirical evidence. We have to use our logical reasoning. We have to infer, and we have to use our imaginations. So we've already talked about what observing means. At this point, you should know it. You're using your senses to gather information. All right, let's talk about data and collecting empirical data. So when I say data is the plural, the singular is datum. Data are the facts, figures, and all the other evidence collected during a scientific investigation. So sometimes our data is qualitative, sometimes it's quantitative. But when we collect that data in a precise, logical, and consistent manner, the data is called empirical evidence. So it's really important that we focus in this class and every time we're doing a scientific investigation with empirical evidence. Again, it's data and observations that have been collected through scientific processes that also explain a particular observations. So all relevant, good scientific investigations involve the collection of relevant empirical evidence to support researchers' conclusions. All right, so I've got Spock from Star Trek up here because this is kind of that mindset of using logical reasoning that Vulcans, if you follow Star Trek, are renowned for, which of course they're fictional, but we're just going with it. So scientists collect data. Okay, they run an experiment, they get their qualitative, quantitative observations. Then they're going to review that figure because they've graphed it, they've charted it, and in that graph and chart, it makes the patterns more apparent. And so when they find those patterns, they need to explain those observations. Now, explaining those observations is when that objective and subjective reasoning comes into play. And if you remember from 7th grade, subjective reasoning is when your own personal feelings come into play, and that's not always fabulous. Instead, we want to be objective. We want the observations to help explain what's going on. So being logical, using reasoning, we then just draw conclusions based on the patterns we see. All right, inference. Inferring means making or explaining those observations we make in a logical manner. It does not mean guessing wildly. For instance, if I look at this picture, you should infer that it's cold outside. Okay, a guess would be they're all going to a party or they just left a restaurant. I mean, that's not based off the observations we're seeing. Instead, they're all wearing winter coats that are buttoned and zipped up. They've got hoods on. We can infer that it's probably cold or was cold when this picture was taken. All right, imagination's super important. It's really the basis of science. You have to be curious. You have to have an imagination. It's what helps all of us to question our surroundings, to design experiments, to solve problems, to see patterns in the data. So without curiosity and imagination, we would probably still be rubbing sticks together back in the day. All right, I mentioned this briefly a few minutes ago, and I just want to review it again, the difference between objective and subjective reasoning or data. Subjective reasoning is based on evidence. We are using that empirical data that we collect to make sound scientific judgments, okay? So this is where we want to be when we're in the middle of an investigation. Subjective reasoning, on the other hand, is based on our personal feelings or personal values. So our opinions are really our personal feelings. So if you look at the difference between the objective and subjective data, it kind of goes with quantitative data a lot of the time. So Susan has a temperature of 39.3 degrees Celsius and is crying. You can't refute that. We can see the tear in her eye and we can assume that the lady took her temperature. Subjective data is Susan saying, I have a really sore head and I feel really tired. Again, you can see where that's kind of qualitative sounding. All right, pseudoscience versus science. Pseudoscience is a set of beliefs that may make use of science, but whose conclusions or predictions are not based on observation, objective reasoning, or scientific evidence. So when we look in the cartoon, why does the sun set? A pseudoscience way could be like, you know, the cute little stories, the sun went to sleep, that your parents told you when you were little, the sun goes to sleep every night, and it's going, I mean, that's pseudoscience. There's no observations on that. Science, on the other hand, is based on that empirical evidence, that data, that sound qualitative and quantitative data that we collect. It's reasoned, meaning it's logical, it makes sense. So in the Calvin and Hobbes commercial, the dad's saying, it's because hot air rises. The sun's hot in the middle of this day, so it rises high in the sky. No, that's not science. Does it sound like science? Yes, and that's what we have to be very, very, very careful of, is sometimes pseudoscience does sound like science, but if you apply a little bit of logical reasoning, well, that's a really cute explanation. It's not true. So we know that the sun doesn't rise and set. It's the spinning of the earth on its axis as it revolves around the sun that causes the appearance of the sun to rise and set. So like I said, pseudoscience can trick us because it may make use of scientific data, but the conclusions of pseudoscience are either based on subjective reasoning or faulty beliefs rather than just really careful examination of the evidence collected. Okay, so understanding other aspects of the world requires training outside of science. So what I'm talking about here is that philosophy, religion, existentialism, all that stuff is wonderful, and that just doesn't have room in the realm of science. I'm not saying it's not valid. Of course you need to be a well-rounded individual, but we're not going to deal with those types of things in this class because we can't observe it, we can't gather evidence about it, and so we can't therefore make logical conclusions. So when you talk about philosophy, what's the meaning of life? Reasons for historical events, like why did really the Civil War happen, and how was it that families were torn apart? I mean, we can't apply scientific, investigations into that. Appreciating works of art and music can't be explained or taught by science. Those are very subjective. I listen to your music, and 9 times out of 10 I think it's garbage, and you think the same of mine. We can't apply a scientific model to say whether it's garbage or not because it's very subjective. It's based on our personal feelings. So those are the elements that we don't deal with in this class. All right, so science and its methods, just to sum everything up, are characterized by an ordered approach to learning about the world. So we are going to systemically and methodically carry out our investigations. So we're going to be objective, not subjective, and we're going to be very observant, and we're going to note all of our observations. Because scientific investigations are well-reasoned, because we take our time, because we write our data down, other scientists are able to repeat or confirm our results. All right, that wraps that one up, and you should have one more coming in the later in the week, and you guys have a good day.